What's up everybody? In this video I'm going to be showing you exactly how to solve these 6 definite integrals, so you leave this video knowing how to deal with these types of problems. So let's go ahead and get started. Here's problem number 1. Before I do anything, I want to give you the formula for evaluating definite integrals. So it's as follows. So it's going to be the integral evaluated from a to b of f of x dx is equal to capital F b minus capital F a, where f is just the antiderivative of f of x. So let's go ahead and apply this to this problem. So this integral here is going to be equal to 2x to the third over 3 plus 3x to the 2 over 2. And we're going to evaluate this from 1 to 3. So let's plug in 3. So we're going to have 3 to the power of 3 over 3 plus 3 squared over 2. And we could put parentheses here just to eliminate any confusion that we might have. And then we're going to subtract this expression evaluated at 1. So this is going to be 1 to the third over 3 plus 1 to the 2 over 2. Sorry if my writing is a little bit messy. Okay, so now let's just go ahead and simplify. So 3 to the power of 3 is 27, and that multiplied times 2 is going to give you 54. So we're going to have 54 over 3 plus 3 squared is 9. 9 times 3 is 27. So 27 over 2. We're still going to have those parentheses there. Subtracted. 1 to the power of 3 is just 1. So we're going to have 2 over 3. On this side, we're going to have 3 over 2. Okay. So at this point, if you have access to a calculator, we could just plug it into the calculator. And just to save you guys some time, I'm sure that you guys know how to add and subtract fractions. So let me give you the answer. Let me plug this into my calculator. So all of this here is just going to be equal to 88 over 3. And that's going to be the final answer for the first problem. So here's problem number 2. So the integral of e to the x is equal to e to the x. And we don't add a plus c because we're dealing with a definite integral. Instead, we apply the limits of integration. So here it's going to be from 0 to 2. So this is going to be equal to e to the 2 minus e to the 0. And e to the 0 is equal to 1. I don't know what e to the power of 2 is, but we can plug this into our calculator to get the final answer. So this is going to be equal to approximately 6.39. So that should be our final answer. Here's problem number 3. So what is the integral of cos x dx equal to? That's just going to be equal to sine x. But remember, we're dealing with the definite integral, so apply the limits of integration. So this is going to be equal to sine pi over 2 minus sine 0. Sine at pi over 2 is going to be equal to 1, and sine at 0 is 0. 1 minus 0 is 1, so 1 is the final answer. Problem number 4. So before I show the solution, I invite you guys to pause the video and try to solve this for yourself. So the first thing I would do is express this as the integral of 1 to 4 of x to the power of negative 1/2, because this just makes integration a little bit clearer. Okay, so this is going to be equal to x to the 1/2 over 2 evaluated from 4 to 1, which is equal to 2 to the 4 1/2 minus 2 1 to the 1/2. Okay, 1/2 is just a square root. So what is the square root of 4? It's equal to 2. So this is multiplied times 2 minus the square root of 1 is just 1. So minus 2. Okay, so then we have 2 times 2 minus 2. So we're going to have 4 minus 2, which is all equal to 2. I know it's a lot of 2's, but this is the final answer. Problem number 5. So what is this equal to? Go ahead and pause the video and try to solve it for yourself. The integral of 1 over x is equal to ln absolute value of x. And applying the limits of integration, it's going to be from e to 1. So this is going to be equal to ln absolute value e minus ln absolute value 1. This is just going to be equal to ln e minus ln 1. Ln e is equal to 1 and ln 1 is equal to 0. So this is going to be equal to 1. That's the final answer. So if you guys recall, absolute values are actually piecewise functions, and it's the following. For x greater than or equal to 0, this is equal to x. But for x less than 0, this is equal to negative x. So what we get from this is that we can actually split this integral up into 2 to make things more clear. For the case where x is less than 0, aka from negative 2 to 0, we're going to have negative x dx. And then we're going to have the case where x is greater than or equal to 0, which is from 0 to 2, x dx. So this is going to be equal to negative x squared over 2, evaluated from negative 2 to 0, plus x squared over 2, evaluated from 0 to 2. So plugging each value in for the first part, we're going to have 0 here, so that doesn't matter. So we could just add a minus and then plug in negative 2. So we're going to have negative 2 squared over 2. Now for the second part, we're going to have plus 2 squared is just equal to 4, and 4 over 2 is equal to 2. And minus, well, you could plug in 0 into this x value, but that's just going to give you 0. So the minus part is not really necessary here. Okay, so all of this is going to be equal. For the first part, that's all going to equal to 2, and then we're going to have a plus 2, and that is obviously equal to 4. So that's going to be the final answer for this indefinite integral. So that's going to be it for this video. We went through all 6 of these definite integrals, and I hope that this gives you guys a better understanding on how to deal with definite integrals no matter where you see them, whether it's on your homework, your study guide, or wherever else it may be. Self-study, doesn't matter. I hope that this video aids you guys. If you guys have any suggestions on any concept you would like me to cover, any problem you would like me to solve, please leave it in the comment section, and subscribe if you would like to watch more math tutorials just like these.